managed switch, there's a feature called CCTV mode, sometimes called long-range PoE mode. Here's what it does in plain language. It trades speed for distance. Hi tech enthusiasts, welcome back to Fast Cabling. So imagine you've just built a gorgeous new baseball complex, 2 main fields, families everywhere, and your clients look at you and says, I want every pitch, every base, every corner covered with PTZ cameras, and I don't want tons of power cabling. Oh, and by the way, those fields are hundreds of meters apart. And that's exactly the project we are walking through today. How this baseball complex solved the over 100 meters PTZ problem without a massive extenders, and how you can do the same. So our clients laid out this simple on paper but tricky in real life. 2 key fields with multiple PTZ cameras and a handful of bullet cameras for general coverage. Also a Wi-Fi access point so players and staff can get online. On top of that, they want security and crowd monitoring. So the rules are as few power cables as possible everywhere on IP, and it has to be reliable on game day. So the first decision was obvious. This is a PoE job. Now if you're new to PoE, Power over Ethernet basically let you send data and power over the same network cable. So one Ethernet cable from the switch to each camera. No extra AC outlets at every pole, less to brick and less to wire. And for this complex, we have more than 20 cameras in total, PTZ plus bullets, so instead of 20 separate power runs, we bring all of them back to a PoE switch. All we need to do is plug your camera into the PoE port. Then it will determine how much power that camera needs, and it delivers it automatically. Easy to install, easy to maintain. But baseball complex is a large site, so we immediately run into one classic limitation. Standard Ethernet and PoE are only rated at about 100 meters or 328 feet. Beyond that, the signal weakens and the voltage drops. That's usually fine in an office building, but on a sport complex, one long run to a far pole can easily hit over 100 meters. And the usual fix is drop a PoE extenders or a small switch somewhere in the middle. That works. But on this project, we wanted fewer boxes in the field, fewer points of failure, and fewer places that need power. So we use a different trick. On our managed switch, there's a feature called CCTV mode, sometimes called long-range PoE mode. Here's what it does in plain language. It trades speed for distance. So when we enable CCTV mode on one of the port, the data rate dropped from 100 or 1000 megabits down to 10 megabits per second. In exchange, that single copper run can now stretch up to 250 meters, which is about 820 feet, without adding any external extenders. So it's perfect for this baseball complex because all of our cameras are within about 600 feet of the switch. So let me show you the setup flow that we used. First of all, I'm going to add another 100 meters to this setup so we can test our CCTV mode. I'm going to unplug that 100 meters cable and join these 2 cables together using a coupler, so now we get total 200 meters. But in real life setup, make sure you use a big row of 200 meters instead of using a coupler to join them together. Otherwise, it might affect your performance. Now we can see our PTZ camera is getting the power, however, it is not getting the data. This PTZ camera is basically dead. So here we are going to exit our VMS and go on and log into our managed switch. After you type in the IP address, type in your username and password so you can log in. After you log in, you can see everything about this switch. First of all, go to our switch config. Then go to port config. Now we can see the PTZ cameras that connected to the switch is at port number 2. So here we are going to select port number 2. Remember, we have to drop the speed down to 10 megabit per second. And make sure you choose full duplex. Then we can hit apply. All right, after you hit apply, make sure you hit save before you exit. Now underneath here, we can see on port number 2, we're getting 10 megabit per second, or you can use your mouse to point at the port so you can see the data. Now we can see it's getting 10 megabits. So now I'm going to open up the VMS. We can see our PTZ camera is connected again. I'll wave my hand. You can see this is live video, and there's no extender in the middle, just one long copper cable straight from our PTZ camera to the switch, and it's 200 meters. Now 10 megabits might sound low, but for a single 1080p or even 4MP security stream is plenty, especially if you're using decent compression. So the cameras get a solid link and we save money and time in the field. So we all know PTZ cameras are power hungry. When you're zooming and moving, especially at nights with IR on, they need a lot more wattage than a typical bullet cameras. The CCTV mode solves the long distance data. But how do we make sure those PTZ cameras still get enough power at the far end of a long cable, like 200 meters? Let me try. Now I'm going to use a tape to cover the sensor so we can turn on the IR infrared. All right, I can see the infrared lights are on. Let's give it a second. All right, now the images has turned black and white. We're still getting enough power. And this is where switch choice really matters. For this project, we use our 24-port, 480 watts L3 managed PoE++ switch with 4 SFP plus uplink. And here's why it's a great fit. First, it's a BT PoE++ switch on the first 8 ports. That means those ports can use all 4 twisted pairs in the cable to deliver higher power instead of just 2 pairs like the older PoE standards. And the cameras themselves are at a 2.3 AT standard, so they only need up to around 30 watts. But by feeding them from a BT PoE++ port, we have plenty of headroom to overcome voltage drop on those long runs. Second, the total power budget is 480 watts. 480 watts give you safety margin for peak loads, cold nights, and future expansion. On top of that, this switch gives you 24 gigabit PoE port, 4 10 gig SFP plus uplink slots, and full layer 3 features like VLANs, QoS, SNMP, and link aggregation. It's not just a power source. Is the core of the network for each field. So now we've solved power and distance, but remember there are 2 fields separated by a few hundred meters. So we need both fields on the same network so our client can monitor everything from one control room. Now running copper between the field will smash into that same 100 meters limit again, and we don't want a chain of extender out in the middle of the complex. That's why we decided to link 2 sides with fiber optic cable. Fiber is the perfect backbone. It's immune to electromagnetic interference and it goes long distance easily. On each field, we drop in the same 24-port 480 watts L3 management PoE++ switch. Then we use the 10 gig SFP slot to create a fiber link between them. And for this job, we are using this pre-made single-mode fiber optic cable. They come with connector factory terminated, so you don't have to polish or splice in the field. Let's plug one end into our switch here. On each string, it has label on them. Let's use string C. Before you plug it into the SFP slots, we'll need an SFP transceiver so we can connect with our fiber optic cable. So just click done. And we'll run this cable to the other switch. We have a bullet camera here. I already connected to an Ethernet cable. So on the other switch, we have the same type of switch. Let's plug in our bullet camera to one of the PoE port. Then we can connect to our fiber optic cable. Remember, we use string C. Make sure you use the same one. Again, SFP transceiver into the SFP plus uplink port. Then click our fiber optic cable. And this switch is already connected to our network video recorder, so everything is connected perfectly. Now we can see we're getting live video feed for both PTZ and bullet cameras. And you may ask, is 10 gig overkill for a baseball complex? Honestly, no. Think about what's flowing over that link. Dozens of camera streams, future 4K cameras. So a 10G fiber backbone is actually a nice bit of future proofing. And because this switch supports link aggregation, so you can even combine those multiple SFP plus port to build a 20G or even 40G backbone later if the site's growth. And there's one last piece we absolutely have to talk about before we wrap up. Surge protection. You can have the nicest cameras in the world, but if a lightning strike or a big surge rises in on your outdoor cable, you're back on site swapping gear instead of watching the game. So for this project, we're going to use an indoor surge protector and an outdoor gigabit PoE surge protector. Let's do it. So this is our indoor surge protector. I'm going to unplug our bullet camera's Ethernet cable and plug it directly into our surge protector first. Now we have numbers, so I'm going to plug it into number 9. Then use a short patch cord to connect port number 9 directly back to the switch. So now we get clean energy back to our switch. Now we also need a solid ground connection from the surge protector to the site's grounding system. That way, if a surge comes in from the field, the protector can ground it before it reaches our expensive switch and camera. Now for outdoor, we are going to use this outdoor gigabit PoE surge protector. It's designed specifically for outdoor PoE devices like camera and access points. And it's rugged stainless steel IP67 housing, so it can live right where the action is in the weather. But I'm taking the neck and the gland out for easy installation. Again, for the outdoor, we are going to unplug the Ethernet cable from the bullet camera and plug it into the input port because the surge will go in here, then deliver clean energy out to our bullet camera. So at the output port, we are going to plug in another short patch cord. And this one has a special DIN rail mount, so we can mount it on a DIN rail. Again, connect it to our bullet camera. Now this is the grounding cable. Make sure you ground it properly. So everything is connected. Now our bullet camera is still getting the power and the data it needs with surge protection. Here we go, I'm going to wave my hand so you can see we're still getting live video feed. So coming to the end of this video, now you might be wondering, can I use that same CCTV mode trick for a Wi-Fi access point that's more than 100 meters away? The answer is no. A Wi-Fi access point really needs high bandwidth, and locking it to 10 megabit per second is going to choke performance. So you can watch our other videos. And if you're planning a big sports facility, campuses, or parking lot project, hit subscribe and stick around. And feel free to drop your questions about this baseball setup in the comment section below. We'll be hanging out there and helping you design your own long-distance PoE networks. Thank you very much for joining us, and I'll see you in our next video.